Hey everybody, Dr. Viso here. In this video, we're going to talk about complement, and we'll talk a little bit about the general properties of complement, some of the functional components to be aware of. Some of them we've kind of already touched on in the previous videos, and then we'll go through the three major pathways, all leading into the common pathway, and then we'll talk a little bit about some of the inhibitors, which makes a really nice transition into some of the disorders of complement, which we'll also touch on. So just to give a very high level overview here, when we're talking about complement, we're talking about plasma proteins that are typically going to be synthesized in the liver. When they're synthesized, again, they're in an inactive state. So they might be in the serum, but that doesn't necessarily mean that they're going to be setting off complement cascades on pathogens. Okay, so usually there's something that is going to trigger activation of the complement system. Okay, so once we get activation of the complement system, which could be by immunoglobulins, it could be by enzymes, certain carbohydrate moieties, which we'll discuss in the next video. Once we get that activation, there's two kind of endpoints to this complement cascade that you want to be familiar with. So the first one is going to be C3b. Okay, remember, so C3b is going to be very much involved with opsonization, and we talked about that previously. C3b and IgG being the two particularly high yield things to be familiar with when you're thinking about opsonization, when you're thinking about triggering that component of phagocytosis. Now, the other kind of endpoint to complement is going to be the membrane attack complex, which that's what this MAC stands for, this membrane attack complex. And as we go through complement, we're going to kind of start at the top. So, we'll start with C1. Okay, so we're going to start with a C1, but then eventually, as we go through the complement cascade, we'll eventually end with this C5, C9 complex. Okay, and this is sometimes referred to as the membrane attack complex, or the MAC. Now, that doesn't necessarily mean that we go, exactly in order here. Okay, so that's not true, but we do start at C1 and then we end at C5, C9. Okay, and then everything in between is what we'll discuss in the next video. Now, do you have to understand every single component of complement? Not necessarily, right? It's not particularly high yield to know that, but there are certain functional components that are very high yield that you want to be familiar with, and a lot of these we've kind of already touched on, so this should be a little bit of a review if you've been following the video series. So we have C3a and C4a, which, remember, sometimes you'll see this written as anaphylaxis, right? So they're going to stimulate anaphylaxis. Now, we're not talking about anaphylactic shock necessarily, but the term anaphylaxis is simply referring to histamine release from mast cells, which is pretty consistent with what a patient experiences when they go into anaphylaxis, right? And so C3a and C4a will be promoting that process that ultimately leads to vasodilation. Now, a lot of this is really just kind of promoting the inflammatory cascade that we talked about in the acute inflammation video. Now, remember, C5a is very high yield because C5a actually does, the same thing as C3a and C4a, but also the thing that it's notoriously known for is its ability to kind of assist with neutrophil chemotaxis, and that's particularly high yield. So neutrophil chemotaxis with C5a, very similar to LTB4, right? We kind of had this discussion, interleukin 8. Those are your big players in terms of stimulating neutrophil chemotaxis to essentially take the neutrophil to the site of inflammation, taxing it over there using chemokines. And again, like we said, the terminal component of this complement cascade is going to be the C5b9 membrane attack complex. And this membrane attack complex, if you can imagine, you have some bacterial cell here. Okay, let's just say we have some bacterial cell, and essentially this membrane attack complex, what it does is it kind of just punches holes here in the membrane of the cell. So it's essentially going to be punching holes in the membrane of the cell, and so this cell will lose whatever gradient it has intracellularly to the extracellular space, and this can rapidly destroy pathogens. And this is essentially what this membrane attack complex is doing. Okay, it's essentially punching holes or perforating the cell membrane or capsid potentially of different pathogens, bacteria, viruses, etc. And where this is particularly useful in general is going to be against gram-negative bacteria. Okay, and this has to do with the cell structure, the cell wall, which is going to be covered more in the microbiology section. But in general, gram-negative bacteria are destroyed much more readily with the membrane attack complex, particularly Neisseria species in general. Okay, and this is going to come into play when we talk about terminal complement deficiencies. For example, if you don't have or can't form this membrane attack complex, you're going to have a really hard time controlling gram-negative infections, or particularly from Neisseria infections in general. So we'll touch on that in the next video. And the last thing that we kind of glossed over a little bit is inhibition with complement, right? So we talked about you can activate this complement cascade to go from C1 to eventually a membrane attack complex and a C3b component that can perform opsonization, but you can also inhibit different steps of the complement cascade. And I'm going to go into a lot more detail on this to come, but we have a delay accelerating factor, DAF CD55, and there's also a CD59, which I'll talk about coming up. And we'll go over the functions of these in more detail, but just to kind of introduce it here, we have activators and we have inhibitors that are going to affect different steps of the complement cascade.